Okay, chaps. So I had a lesson. Olivia was here. I recorded it. It was so bad. My explanation were not good. I just decided to make a whole new video. So I apologize. Apologies, Olivia. I'm going to record this lesson again. Now nobody's here, and I'm hoping I'm going to do a better job. Also, during that lesson, I put some examples which were in the book that involve trig function, and actually we haven't done integration of integral of trig. So yeah, sorry Olivia, I really messed you around. You know, the rest hopefully you'll have a better video. So in this video, and this is really our first integration grade 12 level, is to integrate things like that. Now, so it's basically a product of two functions. Now, we saw in the recap video that if I have a sum or a difference of two functions and I want to find out the integral of that, then I'm simply doing the integral of each one of them separately. The integral of the sum of a function equal to the sum of the integral of each function. Now, would that work for product? If I have, let's say, f of x times g of x, and I want to multiply, I want to do dx, can I just do f of x dx times gx dx? You probably will figure out that no, we don't have an equivalent to the product rule. We have a product rule in derivative, but it's more complicated than that, okay? But for integrals, it's a bit more complicated. Now, I'm going to prove that to you, okay? So let's say I want to find out the integral of x cubed. Now, I know the straightforward doing it is basically saying, okay, it's x power 4 divided by 4 plus a constant c, okay? But let's say instead, I wanted to calculate it as the product of x squared times x dx. Now, according to this, I should have put a question mark. According to the suggested wrong rule, I could perhaps, maybe, for the question mark, do the integral of x squared times the integral of x. But now, what is the integral of x squared? Okay, I'm going to write it here. It's going to be x cubed over 3 plus ac, we'll call it c1. And the integral of x is x squared over 2 plus c2. Now, if you multiply these two brackets, okay, you're not going to get x power 4, right? You're going to get x power 5, it'll be x power x cubed, x squared, definitely wrong. So in other words, this whole thing I wrote here is nonsense. I can't do that, and I don't have that. Okay? So what do we do? Let's make some space. So what do we do when we have a product of two functions? Now, I know I drew this, but actually let's draw this first. If I have something like that, then personally what I would do, okay, what's the difference? Here's power 3, here's no power. So what I would do is just open it up. I'll say, okay, that's the integral of 8x cubed plus 8x dx. And then use that rule that the integral of the sum is the sum of the integral to find the integral of 8x cubed, 8x, no problem, okay? So that's when it's easy to open. But over here, I've got x squared plus 1 cubed. So I really need to write x squared plus 1 times x plus 1 times x squared plus 1. And if I want to start opening it, it's going to be a nightmare. Okay, I know you know formulas of cube, but they're a bit of a nightmare formulas. And start opening up, we're going to have a million terms here. It's going to take a long time. So sometime you will have to do it. There's no way around. But now I want to show you a little cunning method that works sometime. Okay? Okay. So what should I do? Well, I have to do a bit of a guess. It's a bit of guesswork integration. Okay? Now, one of these is going to be some kind of a function, f of g of x. Okay? So I've got x squared plus 1, that's the function. And a function of function, so I'm cubing it. Now, what might be the case is that this one the thing I'm multiplying it is simply the derivative of x, the derivative of the inner function. Because think about it, what's the inner function here? X squared plus 1. The derivative of x squared plus 1, okay? Well, it's not 8x, it's 2x, but it's very, very close. How does that help me? What I'm going to do, I'm going to say, okay, I'm going to have x squared plus, the answer that I'm suggesting might be the integral of this one. X squared plus 1 power 4. That could be, it might not be completely the answer, but it will get me close to the answer. Now, when Olivia was here earlier, she said this kind of method is a little bit like a trig identity. You know, when you have to prove that this side equal to that side. And what you often do, hopefully, you start from the left-hand side and make yourself all the way to the right-hand side. But in a really difficult question, you start from the left-hand side, you get somewhere, you kind of get stuck, and then you go to the right-hand side and you try and swim the other direction, and hopefully you meet somewhere, and then you can write the whole thing. That's what we're doing here. So we're looking for that function, okay, right? Usually it's going to have the higher power, and we think, okay, maybe my answer is something to do with that. Okay, now we're going to start writing on the other side here. We're going to take x squared plus 1 power 4, and we're going to do the derivative of that with respect to x. What will I get? I will get 4, okay, that jumps out, times x squared plus 1 power 3. All right, okay, I've got x squared power 3. That's pretty good. I've got 4 and I've got 8x. But don't forget, we need to time it by the inner function, which is 2x. So really, this is actually 8x, x squared plus 1 cubed, which is exactly here. Now, if you remember in the recap, I said that the integral of a derivative of x is simply the function. Okay? If I do a function and I do a derivative of that, I'll get a derivative. If I do the integral, I'm going to get back my function. So what did I find out here? I found a function that if I do this one, if I do a derivative, I'm going to get that. But that is exactly the same that I've got here. So that means if I integrate this function, I'm going to get this function. So the answer is this, plus a c. Okay, because we always have a constant of integration. Okay, and you can just test it. You can test. If you do, I mean, what does that mean? If I integrate this, I get this function. That means if I do a derivative of that, I should get this, and I just saw that it is. Okay, so in this case, it was very easy example. There are harder ones, which we're going to do now. Okay, so now we're going to we're asked to integrate this thing. Again, I've got a product function. I can't use this nonsense rule, but my suspicion that one of them is a function, and the other one is the derivative of the inner function. And it's usually the one with the power, or at least the higher power, the power really, that will be the function. So I'm expecting this is to be the function. So straight away I make a suggestion of 4x squared minus 1. What's the integration of that? Well, that must be 6. Okay, so it might be something like that, and already I'm going to put the constant. Okay, I'm going to put a question mark here, because as we will see, this actually not exactly going to work. You'll see why in a second. Now I'm just going to test that the derivative of the inner function is 8x, and it really is 4x squared. What's the derivative? It's 2 times 4x, 8x. So it seems to work, but you'll see we have a little bit of a problem. So here on the other side, like on the other side of the trig function, trig identity, I'm going to do the derivative of 4x squared minus 1 squared power 6, which is my suggestion for the answer, with respect to x. Okay? The answer is going to be 6, 4x squared minus 1 power 5. So far so good, I've got power 5. And now I need to multiply by the derivative of this, which is 8x. Now that, if I could just take that, that's exactly this. So that seems to be all right, but I have that annoying 6 bit. I need to get rid of that annoying 6. Okay, because remember, this, if I leave it like that, the derivative of this is 6 times the answer that I need. So I need to get rid of 6 by dividing it. But like, you know, from algebra, day 1 in algebra in grade 8, you know that if I divide this by 6, I have to divide this side by 6. So the function that I'm looking is not 4x squared minus 1 power 6, but it is, sorry, should have put that here, it's 4x squared minus 1 power 6 divided by 6. Okay, if I do that, if you just look at this as well, what am I going to do? Let's just see how it works. If I do the derivative of that, let's start from the beginning to see. So I've got the derivative of, it will be 4x squared minus 1 power 5 times 6, the 6 jumped up, but I still have that 6 waiting for him, lurking to cancel him out, and time it by 8x. And that cancel out, and voila, we got it. So by testing it on the other side, like in trig, I then adapt the solution. And the solution I need to multiply, divide it by 6. So, okay, let's try a couple more examples. Okay, next question. Again, you can see I've got usually a short function times like some polynomial with a power. And one of them will be the function, the one with the power, and the other one will be the derivative of that. You can see that this is going to be almost the derivative of this, okay? 3x squared plus 2 will be 6x. Okay, I don't have x, but I don't have 6x, but I have x. So up to a multiple of a number, I can sort out this thing like I had divided by 6. So it's important, first of all, to suggest the type of solution and then try and perfect it. So the solution will be something like that, 3x squared plus 2 power 5, right? It always goes up. And then I'll put plus c. And then we're going to the other side and we're going to find the derivative of 3x squared plus 2 power 5. Check out that I'm leaving some space because I know I'm going to have to divide it by something. Okay? I had to learn it with Olivia's lesson here, which was not as good. And I was not dividing, I'm differentiating with respect to x. Now if I do that, I'm going to have the 5 jumping out here. 3x squared plus 2 times 6x. Okay? And if you don't mind, I'm just right. 5 times 6 is 30. So I'm going to put it as 30x. Okay? That's the solution. Okay? Now, I've got, sorry, that should have been power 4, right? Can't forget the power 4. So that's good. X is good, but I've got that extra 30. How do I get rid of this 30? Of course, we divide by 30, but if we divide the derivative by 40, we must have do the derivative of the original function divided by 30 as well. Okay? So now I'm going to have to divide the solution by 30. And I can test again. Okay? You can do the derivative of 3x squared plus 2 power 5, all that divided by 30. Okay? The power 5 doesn't, we're not doing 30 to the power 5, right? The power 5 is just with the brackets divided by 30. You'll see you will get the same. You'll get this. So that's the answer. Ta-la-la! Okay? Let's see if there's another, maybe one last example to do. Okay, 2 more examples. Okay, now it looks like I just have one function. Okay? Now again, it's going to be madness to start opening. That's power 5. It will be madness. So what I can do is like, I guess you can say a trick. I can say, all right, there's a 1 here. Okay? Now, how should I do it? Nah, let's just leave it that. Okay, so the function, you can kind of, hopefully you're getting the feeling. It's a lot of guesswork, okay? The function, the solution will be something like 3x minus 4 to the power of 6. Always above. We're going to divide it or multiply it by something plus c. Then on the other side, I'm going to try and do the derivative of that. 3x minus 4 power 6 with respect to dx is going to be 6. 3x minus 4 times 3. Okay, because the derivative here is 3. and our 3 times 6 is 18. Okay, so we got 3x minus 4, sorry, that's again power 5. But now I've got too much of the 18 here. So I'm going to divide by 18, divided by 18. So the solution have to be divided by 18. Pretty simple, isn't it? Okay, let's do the last one. The last one. Okay. Yeah, I thought I'll do one with square root. Square root of 5x minus 2, and then there's dx here. Okay? So, as always, just like in all the other examples, it's worthwhile writing it again, but in terms of exponents. So that's power half dx. Right, so the suggested solution is going to be 5x minus 2 to the power of what? Let's get rid of that wrong rule, it doesn't exist anymore. Okay? Okay? So that, the power should be 1 above that. So it should be 3 over 2. Do you know what? Yeah, okay. Yeah, 3 over 2. That is the suggested solution. Now, if I think about it, actually I can work it out straight away. Maybe I should do it now. Because, okay, I'll do it, and then I'll show you that it works. So I know that if I do, in my head, if I do the derivative of this, okay, I'll get 5x minus 2 power half, but then the 3 over 2 will jump. So I need to prepare something for it to kill it. As soon as the 3 over 2 jumps here, 3 over 2 times 2 over 3 is 1. So that's going to kill it because I've got 1 here. I've got no constant. So I sorted that out, but there's one more constant jumping out, going to jump at me. He's going to jump with me, but later the 5 is going to jump at me as well because there is the derivative of the brackets. So I need to prepare something here that will kill it, assassinate him, divided by 5. Okay? So in other words, it will be 2 over 15. And obviously plus a c. Okay? Let's see that it works. I'll just check first of all it does work, and then let's see that it works. Okay? So if this is the right solution, that means that if I do the derivative of 2 over 15, 5x minus 2, 3 over 2, plus a c. I'm not going to write the c. If I do the derivative of this with respect to x, what should I get? I should get back this, okay? Because that's how integration and derivative works. They work in reverse order. So I'm going to take the constant, leave that constant there. The 3 over 2 jumps out, okay? Then I'm going to have 5x minus 2 power half, which is already good because that's square root. And I need to multiply by 5. Okay? So that, let's get the red pen. Okay? The 2's cancel. The 3 times 5 is 15, so that cancels with that. And I end up in square root 5 or 5x or minus 2. Okay? So in this case, I could actually do it without going from the other side of the equation. I'm just going to check. Yeah, I think that's it. Let me just tell you one thing. I'm also going to send it on the WhatsApp. When you do, there's basically a bit of a glitch in this exercise. In this exercise, some of the examples included trig functions, cosine and sine. Now, unfortunately, Olivia, I did it with her now, but I just forgot that we didn't teach you integrals of cosine and sine. So I don't know why, it's a bit of a glitch in the book, okay? Only the next section we teach trig of cosine. So what I'm trying to say, all the questions that have sin and cosine in this exercise 2.1, don't do it, okay? Cheerios, good luck.